All right, so anyone remember by any chance what a rational function is? It's okay. All right, so a rational function is a function in the form of f of x equals to some function divided by another function. So I'm going to call that function n of x, and I'm going to call the other function d of x, where if you have a fraction, we should know that the denominator cannot equal to 0, and more importantly, n of x and d of x are polynomials. So in other words, a rational function is the division of two polynomials. Okay, very, very important for us to know this. The denominator of a fraction cannot be 0. Okay, that's something you learned back in, I think, grade school. That still should stand true for a function, right? If you can't divide by 0, then that means the denominator of a function cannot be 0 as well. Okay. Rational functions are not going to be continuous. So we just finished talking about polynomials. One of the characteristics of polynomials, and one of the main characteristics we talked about specifically when it came to graphing, was the fact that they are continuous. A rational function, on the other hand, does not have to be continuous. Matter of fact, most of the time they will not be continuous. There can be occasions where they can be continuous, but for the most part they will not be continuous. And the reason for that being is because we have things present such as vertical asymptotes and holes. Okay? So the first part of the lesson today is just going to be a bunch of information that I'm going to provide for you. Okay? We'll do examples later on, but for the beginning, it's just going to be a whole lot of information. Now remember, hopefully you remember a little bit of this information from Algebra 2. This should just be a review for you, but if you're learning this for the first time, I'm going to go a little faster than I would have if you were learning this for the first time. Just kind of throwing that out there. Okay, so let's go ahead and talk about some of the information that you're going to need to figure out in order to graph a rational function. Number one is, let's figure out what vertical asymptotes. How do we find them? Does anyone remember how to find vertical asymptotes?
Set the denominator equal to 0.
Very good. You're going to set the denominator equal to 0. Fantastic. And then we go on to something called horizontal asymptotes. Okay. Anyone remember by any chance how to find those?
You set the horizontal, not horizontal, do you set the numerator to be 0 or something like that?
No, that's actually when we set the numerator equal to 0, that helps us find the X-Intercepts.
Okay.
So the horizontals, those get a little tricky. I think a lot of you guys learned this. Maybe if I say these words, you'll remember Bobo, button. Some of you guys learned it that way. So in other words, if you don't know what I'm talking about, let's just go ahead and tell you how to find them. Okay, you have to compare the degree of your numerator versus the degree of the denominator. Okay, and there are three scenarios that could happen logically. Okay, logically, the numerator, and I'm talking about the degree. Okay, the degree of the numerator could be smaller than the degree of the denominator. Does anyone remember what happens when that is true? If the degree of the numerator is smaller than the degree of the denominator. Okay, we have an asymptote at y equals 0. Guaranteed. I don't really care what the numbers are. If the degree of the numerator is smaller, you automatically have an asymptote at y equals 0. Scenario number 2. If the degree of the numerator is equal to the degree of the denominator, you will have an asymptote at y equals a divided by b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So in other words, You got to find out what the leading coefficient is for the numerator and the denominator and divide them. Whatever the division of those two numbers is, that's where your horizontal asymptote will be located. Okay? And lastly, number 3, our last scenario would be if your numerator, the degree, is bigger than the degree of the denominator, you have something called a slant asymptote. This should be relatively new for most of you, unless you had an Algebra 2 teacher that went above the standards that are provided by the state. The slant asymptote is maybe something you've heard before, but I'm going to assume most of you guys haven't. Okay. In the past, you were told that when the numerator had a bigger degree than the denominator, you did not have an asymptote. Okay. In reality, you do have an asymptote, and it's called slant asymptote. So this should be not a horizontal line, right? Any thoughts of what do you think a slant asymptote is, or how does that look? The key word here is slant. Do we know what slant means?
It's like angle?
Yes. So it's going to be basically an asymptote that has an angle to it. Okay. So it's not going to be a vertical line or a horizontal line. Okay. It's going to be a line that is at an angle, or in other words, a line that has an actual slope other than 0 or undefined. Okay. Now, how do we find those? To find the slant asymptote, you are going to divide the numerator by the denominator. Okay? So you're literally going to have to divide. So luckily for us, we've already covered long division and synthetic division. So we can use whatever you think it's appropriate for each case, whatever case you're dealing with. Okay? How are we doing? Any questions thus far? I know I've just provided you with a lot of information, but I hope fully haven't overwhelmed you. We're good? Okay, so this is asymptotes. What else could be present on a rational function? Holes. Very good. So now we're going to talk about how to find holes. Okay. If x minus a is a factor of the numerator and the denominator, what does that mean as far as, like, think about what happened last class. What happens when you have the same factor both on the numerator and the denominator? They cancel out. So if they cancel out, that means you're going to have a hole, guys. So this is what it's trying to say. If you have the same factor on the numerator and the denominator, it's going to cancel out. Then there is a hole at x equals a. So not only do you cancel that term out, but you got to figure out what makes that term be 0, and that's where you're going to have a hole. However, we are interested in finding out the exact location of the hole, which means if we want to find the exact location, we have to have an x coordinate, and we also have to have a y coordinate. Okay? So to find the hole, to find the exact location, you will take x equals a and plug into f of x. But you will use the simplified version. And I'll talk to you about what that means. We are going to do examples. So after you figure out what that x value is, you'll plug it in back into the function, but you'll plug it back into the simplified version of the function, and then at that point you're going to have x equals a, not x, a comma f of a, and that should be the exact location of your hole. Questions about holes? Okay. The next thing we need to talk about is then X-Intercepts. So if you were paying attention, I think you might have heard me earlier. How do you find X-Intercepts?
I think you set numerator.
Set the numerator equal to 0. Very good. We're going to talk about Y-intercepts. How do you find Y-intercepts? For any function. It doesn't matter that we're talking about a rational function, but for any function, how would you find a Y-intercept?
X equals 0.
Cool. So you're going to plug 0 for x and solve. And lastly, one thing I want to mention, I don't really need to write this, is the idea of multiplicity still can help us when we're graphing. So remember, multiplicity allows you to know whether you're going to cross the x-axis or whether you are going to just touch it and turn around. Okay, so the idea of multiplicity can still help us out. All right, and then I do have one more thing to talk about before we move on, and it's going to be something very new for you. Okay, my question to you is, can we cross an asymptote? Based on your knowledge, your answer should be that we cannot. I see a lot of you guys shaking your head. Good. You can't, right? You were told that an asymptote is something that you approach and that you cannot touch, right? All right. Did you guys buy into that idea? Like, do you believe that? Like, that is something that you were told, so you should be like, okay, yes, I believe that to be true. Okay, good. At this point, now that you truly believe that, I have to tell you that there are occasions where we can actually cross an asymptote. Okay, but I need you to understand the following. It wasn't, we weren't lying to you just for the sake of lying. I think, you know, your Algebra 2 teachers give you this information to get you to buy into the idea that an asymptote is really something that you just approach. That's really what I need you to understand. Okay? Think of an asymptote as a magnet. Okay? It's going to continue to attract you towards it, and you're going to have to get close to it. Okay? But I don't know if you've ever taken two magnets and tried to push them together. They just kind of push each other apart, right? So that's how, when I used to teach Algebra 2, that's how I would convince you guys, like, oh, it doesn't touch it, right? All right. There are certain occasions, it's not very common, but you can indeed cross an asymptote. Now, you can't cross any type of asymptote. So let's talk about the three asymptotes. Okay, so vertical, horizontal, and slant. So the question is, can we cross each one of these? All right. First one, the vertical is going to be no. We cannot cross that. And I'm going to show you an example here as to why we can't. Horizontal, yes, we can. And slant, yes, we can. All right. This too, I'll talk about during our examples. But the vertical, why is it that I cannot cross a vertical asymptote? Well, let me give you a quick example as to why. Let's say that you had an asymptote right here, vertical asymptote there. And let's say you have a horizontal asymptote right there. And let me give you an example. Let's say that your graph looks something like this, and you decided to actually go across. You with me? Now the other part, you guys have done this in the past, so you should assume that the other part would be maybe down here. And it's going to look something like that. Okay? Now, in order for us to know whether something is a function, it has to pass a very famous test known as the vertical line test. If you were to perform that test on what I just drew, it's going to fail. Do you guys see why?
Because the vertical asymptote.
Because if you cross this vertical asymptote, that means that somewhere along this line, if I were to draw a vertical line, somewhere along there I'm going to be touching twice, which means that this is not a function. Okay, so vertical asymptotes, if you ever cross them, you're going to break the #1 rule of what it is to be a function. So that's the reason why you cannot cross. Horizontals and slants, you can cross them and still be a function. Okay? All right. That was a lot of information. Do you have any questions before we begin trying some problems?
Wait,
Yes. You're muted.
for the horizontal asymptote, just because it doesn't touch it twice, that means that you can you could cross it.
Right. So like, let me show you what I mean by that. So let's say hypothetically speaking, so we've got, here's your X, here's your Y. Let's say we have a vertical asymptote right here, just like before, and then we got a horizontal here. And now let's say our graph looks something like this, okay? So we've got that part right there, still no problem. Now let's say the graph is down here, and let's say that I do attempt to cross that asymptote, and then I just continue going that way. Cool? So here's my asymptote. Now, by the way, I'm exaggerating the crossing so you guys can see it. These things are very, very hard to spot, okay? You would actually have to be looking for it in order to find it. But as you can see, if I were to perform my vertical line test, I'm not going to have a problem. This is still going to be a function. But what I do need you to understand is the following. Even though I crossed it, I'm still staying close to that asymptote. It's just very hard for me to show you that, so I'm showing some space there, but this is going to continue to stay close to the asymptote. Cool? And if you do a slant, so let me go ahead and give you guys a preview of what a slant asymptote looks like. So let's say we have X and Y axis. Question. Can I have a horizontal and a slant asymptote on the same graph? Yes, no, what do you guys think? Horizontal and slants present on the same graph. Look at your rules. How do you find a slant?
Numerator divided by denominator.
So, but before you do that, you have to make sure that the numerator is bigger, right? So if the numerator is bigger, then you'll have a slant. But if the numerator is bigger, can you have a horizontal? All right, hopefully you guys are just staying quiet because you don't want to talk, but no, you can't have it, guys. Like, think about it. There was 3 scenarios, right? It was either your numerator was smaller, your numerator was bigger, or your numerator was equal, right, to the denominator. If the only scenario for a slant is when it's bigger, then that means that you cannot have a horizontal, okay? You can't have them both present at the same time. All right, so let's say we have a vertical asymptote about right here. And let's say that we have a slant. Here's what a slant can possibly look like. Cool? That's a slant asymptote. And here's what hypothetically a graph can look like. Okay, let's say we have this part up here, and then it's going to look something like that. And now let's say we have this part right here, and then let's say I want to investigate if it crosses, so I'm going to go ahead and cross it, and then go that way. By looking at this graph, would it still pass the vertical line test? It would. So it is possible for us to cross a slant asymptote as well. Okay? Questions about anything thus far?
How is the graph going through the asymptote?
I'm going to show you here, like right here. I mean, I'm trying to physically just show you where it's happening. How is it possible to happen? I'm going to show you mathematically here in just a minute.
Okay.
Cool?
Yeah.
All right. Any other questions, guys? All right, so we're ready. Let's do this. Okay. I gave you all of the information that you need to look for, but we haven't really come up with a strategy. So let's come up with a strategy. Okay. Step number 1, regardless of what you are doing, what you want to find first, in my opinion, personally, you have to factor out the expression. Factor out the numerator and the denominator. Why would I want you to factor out the numerator and the denominator?
You could find other stuff like holes and stuff.
Things that cancel. In other words, remember the first thing you did on the previous lesson was try to simplify the expression. That's all I was asking you to do. It's because that's literally the first step for graphing rational functions. And then the first thing is going to be find the holes. If applicable. Doesn't mean it has holes, okay? Step 3, after that, my personal recommendation is to find intercepts. Whether I'm talking about X or Y intercepts, whatever you want to find. Cool? Step 4 would be to find asymptotes. Step 5, find any extra points you may need, and I'll talk about that in just a minute. Step 6, find out if the function crosses the asymptote, and I'm going to show you how to do that. Okay, and then finally 7, go ahead and graph. So here's going to be our strategy. There's 7 steps to this. Factor, find the holes, find intercepts, find asymptotes, find any extra points you may need, find out if you're crossing that asymptote, and then once you have all that information, you should be good to go and graph. Okay? Alright, are we ready for our first example, or do we need a little break? Speak, or I will continue to go like with the lesson. Break, or do we keep going? Okay, keep going. Alright, here we go. We're going to start out with a baby problem. Okay, remember guys, I don't know, I've told you this before, while I'm doing this thing, like the chat is really not something that I can see. Okay, so if you are saying something on the chat, it's better for you to speak. Example number 1. We are going to graph the following function. We're going to start out with a baby problem. Okay, f of x equals to x plus 2 over x minus 1. Okay, alright, so follow our steps. We need to factor this out, but is there really anything to factor out? No. Okay, step 2, find the holes. Is there any holes? No, right? So holes, we're going to say none. Nothing canceled out. Okay, let's find our X-intercepts and our Y-intercepts. So how do I find the X-intercepts again?
Set numerator equal to 0.
So this one would give me what if I set the numerator equal to 0?
-2.
So that means that x equals -2 would be an X-intercept. How do I find a Y-intercept? We're going to plug in 0 for x. So if we plug in 0 there, that gives us 0 plus 2 is 2. 0 minus 1 is -1. 2 divided by -1 would be -2. Are we good so far? Sweet. The next thing we're going to find out is our vertical asymptotes. Do I have any, and where? Yes, it would be at x equals 1. We set the denominator equal to 0. Very good. Now the question is, looking at this graph, am I going to have a horizontal or am I going to have a slant, and why?
It would be horizontal because the 2 degrees are equal to each other.
Good. This has a degree of 1 and that has a degree of 1. So what happens when the degrees are the same? How do I find the horizontal?
You would divide the leading coefficient of the numerator by the leading coefficient of the denominator.
Cool. The leading coefficients are 1. 1 divided by 1 is 1. Very good. Okay, so we have a horizontal. That means by default we do not have a slant. Now, in my opinion, we have enough information to try to attempt to graph this. Now, there's two steps we haven't talked about. Number one is you can find any extra points you need. I'll show you what that means in just a second. But number two is how do we figure out if we cross something? Okay, we have to check that before we start. Well, what is the only asymptote I could cross for this graph? The y equals 1. Here's the keyword, y equals 1. You want to know whether or not this function, so this function right here, is ever going to be at y equals 1. So mathematically speaking, how would I do that? Or how could I?
Y equals 1 for A. I mean, y equals 1 for y.
Exactly. Y is equal to 1. Remember, f of x is another way of saying y. So, to find a crossing, we set f of x equal to the asymptote that we have in question. So in this case, the question is, does it cross equals y equals 1? So we're going to go ahead and do that. We're going to have x plus 2 divided by x minus 1. And when you're questioning something, you put a little question mark because you're not sure. Does it equal to 1? Okay? Now, having that little question mark is just really for you. Okay? Treat this still as an equal sign. Okay? So how would you solve this type of equation? Would it help you if I wrote it as 1 divided by 1? What do you do when you have a fraction equaling to another fraction? What method could you use? Cross multiplication. So we're going to multiply this by that, which gives you x minus 1. I'm still questioning whether they're equal to it. And then x plus 2 times 1, so that's going to be x plus 2. And then what do you do after that? Yeah, we're going to try to solve by combining like terms, right? So you got to get x's with x's and whatnot. Okay, so let's say I subtract this x, which means I got to subtract an x from that side. That leaves me with negative 1 on this side. Is that equal to 2? Is negative 1 equal to 2? All right, do you guys see how after I set this equal to each other and I try to solve this, I'm getting a statement that mathematically doesn't make sense? Because this doesn't make sense, therefore, we do not cross the asymptote. And that's important for us to know. So we're not going to cross it. Okay? So now we have everything we need. We're ready to try to sketch this out. So I'm going to go ahead and draw a coordinate plane. And I'm going to go ahead and start using the information that I have. First of all, I have an asymptote at x equals 1. So we're going to go ahead and have a vertical asymptote at x equals 1. And then at y equals 1. By the way, I have grid paper, so I'm counting each square as 1 unit. And then according to the other information that I have is that I have an x-intercept at negative 2. So at negative 2, that would be about right here for me. And I have a y-intercept at negative 2 as well. So that would be about right there. Okay. Here's what I know. These 2 points have to connect. So I know that I have to do this right here. They have to connect. And I'm also going to use my knowledge of asymptotes. Remember, asymptotes are going to be like magnets. So this point right here and this vertical asymptote is going to pull me towards it. So I got to follow it forever going downwards. And then this horizontal asymptote is going to take this point right here and it's going to pull it this way forever. And I'm not going to cross because I figured out that I do not cross. Cool? Now, I need to figure out what's going on the right-hand side of x equals 1. So you have 2 choices, and that's where I meant find some extra points. Okay? So to find an extra point, you just have to figure out what is a x-coordinate that you can use from this side of the vertical asymptote. Which in this case, I'm going to keep it simple. I'm going to use 2. So if I go back to my equation and I plug in 2, so that gives me 2 plus 2 over 2 minus 1. So that's going to give me 4 over 1. So that means I have the point 2, 4. Which means I can go into my graph and plot that point. So that's 2, 1, 2, 3, 4. That would be about right there. And personally, here's my recommendation. You can find another point if you like, but honestly, from here you know that this asymptote is going to pull you that way. And you know that this asymptote is going to pull you that way. So our graph should then look something like that. That will be our final product. Any questions of what happened? This was an easy problem to start with, but I think it's a good problem to start with. There is one last thing I'm going to ask you about graphs, and I'm going to ask you that once you are done looking at that graph, can you tell me what the domain of the function is? So, looking at that graph, what do you guys think? What's the domain of this thing?
All real numbers, but x does not equal 3.
Right, so you're going to be able to have any number except this vertical asymptote. So there's two ways that you can tell me that. Number one, you could say from negative infinity all the way to 1 and from 1 to infinity. This is called interval notation. Or you can use something called set notation, which looks like this. X is equal to, because we're talking about the domain, the set of all real numbers such that x does not equal to 1, and you close the set. Either notation I'm okay with. I personally don't care. What I don't want to see is now you're at a higher level of mathematics. Here's what I don't want to see. If you just write x cannot equal to 1, I'm not going to give you full credit. Cool? You either give me the interval notation or you give me the set notation. Any questions about that? All right. Are we ready to step it up a notch? That was kind of a baby problem. We ready? Sweet. Let's go ahead and try another one. So same thing. We're going to graph. And this time, let's say we have something like this. X divided by x squared minus 2x minus 3. Alright, so first step is to factor. So we're going to rewrite this as f of x equals x divided by what? What does that factor into? X minus 3, x plus 1. Cool. Do we have any holes? Nope, nothing canceled. Okay, X-Intercept. Set the numerator equal to 0, so it'll give us x equal to 0. Y-Intercept. What do I do to find the Y-Intercept? We're going to plug in 0 for x. So that's 0, and that's 0. So that's going to be 0 divided by negative 3, which is 0. Cool. All right. Vertical asymptotes. Do we have any? And if so, where? Negative 1 and 3, right? We got to set the denominator equal to 0. Okay? Now look at your initial function. Was this a case in which the numerator was bigger, smaller, or the same as the denominator?
Smaller.
So what does that mean? Good. Horizontal asymptote at y equals 0. Okay? What else do we need to find?
you could find if you could cross the asymptote.
Okay, does this thing cross? So how do I do that again?
You said y y equal to the horizontal asymptote.
You said the function equal to the horizontal asymptote.
Yeah.
Cool. So in this case, our horizontal asymptote is 0, so we're going to set that equal to 0. Okay. Once again, would it help you if I put a 1 here? 0 divided by 1 is still 0, right? So that means we're going to have to cross multiply once again. X times 1 is x. X squared minus 2x minus 3 times 0 gives you 0. Does this make sense? Like, I mean, this was very easy. Did we get a statement that makes sense? X equals 0. Yeah. Guess what? Yes. So we cross. Yes. But where? Where do we cross? 0, 0. Think this through. By you setting this equal to 0, you found out the x location in which you're crossing. But you already knew the y location. So it's 0, 0. Cool? Alright, so now we'll find some extra points if needed, but let's go ahead and try to graph this. Here's the x and y axis. Alright, we've got a vertical asymptote at -1. A vertical asymptote at 3. A horizontal asymptote at 0. And we have an x and y intercept at 0. So guess what, guys? We didn't even really need to do all this work. We already knew it was going to cross because of our x and our y intercept 0, 0. Yes? But that's all the points I have, right? I only have 1 point. So this one, it would be very helpful for us to go find some extra points, okay? So I'm going to just make a little table here where I'm going to come up with all these extra points. So what are some x values we want to try? Okay, we'll try 1. So what I'm going to do is I'm going to go back. Instead of using the original statement, I think it makes it a lot easier if I just use the simplified version, because that's just going to be 1. What's 1 minus 3? It's going to be -2. And then 1 plus 1 is going to give us 2, which means that it gives us a -1/4. So I can plot that point. So that'll be 1 comma -1/4. So it'll be about, I don't know, right there. Cool. Now, with this point, I know what's going on in this middle section. So let's talk it through. I know these 2 points have to connect, right? And then I know that this asymptote is going to pull me towards it. Now, here's why I know it's going to pull me down. I can't go back up because if I went up, I would have to cross the x-axis again, right? And I don't have another x-intercept. You guys with me? So I knew I had to go down. Now here's my question. Remember how I said the idea of multiplicity can help us out? How many times did the x-intercept show up? Well, remember, to find this, we set the numerator equal to 0, right? So x equals 0. That would be 1 time, which is odd, which means we cross. So by me knowing that I crossed, then I automatically know that this thing has to go up. So that's why I say multiplicity can really help you out. All right, so now that we've got that middle section, now we need to figure out what's going on the right, on the left. So pick an x value on the right and 1 on the left. -2 and 5. All right, so we're going to go back up here again. So if I plug in -2, I'm going to get -2. All right, -2 minus 3 is going to give us a -5. -2 plus 1 is going to give us a -1. So that's going to give us what? A -2/5. All right, so at -2, that would be about right here. -2/5 would be about right there. And the fact that I know the definition of asymptotes, that means I've got to go that way, and I've got to go that way. Cool. And then now if we try 5, So that's going to give us a 5 here. 5 minus 3 is 2. 5 plus 1 is 6. So that's going to give us 6 times 2 is 12. So that's going to give us 5/12. So at 5, so let's see, 3, 4, 5, 5/12 would be, I don't know, maybe very close to the asymptote. So then it's going to look something like that. And we should be done with our graph. We've got everything we need with the exception of what is the domain of that thing. So now that it's done, can you tell me what the domain is?
Wouldn't it just be all real numbers, so you can be equal to either of the numerical asymptotes?
Very good.
Write that in set notation.
Yep. So all reals except -1 and 3. If you decide to do interval notation, then you would have to do -infinity to -1, union -1 to 3, union 3 to infinity. Either notation is fine with me. Okay? All right, any questions on that one? All right, then we are ready for our last problem of the day. It's been a long day, I know. Here we go. We're going to graph. And the question that I would like to graph would be f of x is equal to 3x squared plus x to the third power divided by x squared plus 2x minus 3. Okay? So here we go. Step 1 will be to factor out the expression. What happens on the numerator?
I think you could take out x squared.
Cool. If I take out an x squared, then I'm left with 3 plus x. Cool. Denominator wise, what does that factor into?
X plus 3x minus 1.
X plus 3x minus 1. Very good. All right. Does anything cancel?
The x plus 3.
Good. I did this on purpose just to make sure, like, is it the same thing to do 1 plus 2 as it is 2 plus 1? So, is it the same thing to say x plus 3 as 3 plus x? Good. That cancels. That's the first time something has canceled. Which means if it cancels, what do we have?
Whole.
We do have a hole. Here's the first problem where we have a hole. And we have a hole specifically at what x coordinate?
X equals 3.
-3. How do I figure out the y coordinate of the hole?
Plug in -3 to x.
Good. Where do I plug it in though? Do I plug it in into this equation or this equation? The simplified version, guys. Okay, so we're going to go into the simplified equation and we're going to find what is f of -3. So in this case, it's going to be -3 squared over -3 minus 1. So that gives us a positive 9 over -4. Does that reduce? The answer to that should be no. So that means the exact location for this would be -9/4. Cool? So this is the first problem where we had a hole. When you have a hole, guys, you will utilize this part, the simplified part of the function, for the rest of the problem. You will not go back to this. Okay, so we're going to utilize this for the rest of the problem. Okay. Based on this, do we have any X-intercepts? And if so, where are they? Set the numerator equal to 0, right? So if I set the numerator equal to 0, so x squared equal to 0, which means x equals 0. What's the multiplicity of that? Multiplicity of
2.
2. Very good. That's going to be important for us to know. Why do we know it's 2?
So x squared.
Yeah, if you take the square root, that gives you plus or minus 0, but is plus or minus 0 a thing? No, but that still means it showed up 2 times. Okay? Cool. All right, Y-intercepts. Y equals what?
0.
Good. 0. If you plug in 0, 0 squared is 0. 0 minus 1 is negative 1. 0 divided by negative 1, still 0. Okay. Vertical asymptotes. Do we have any?
Yep.
X equals 1. Very good. Remember, we're going to utilize the simplified version. If you go back to this, you're very prone to say that x equals negative 3 is going to be a vertical asymptote. However, you can never have a vertical asymptote at the same location of a hole. The hole will overtake anything. Okay? So always utilize the simplified version. Wait, now look at this simplified version. Compare the degrees. So what type of asymptote would I have? Horizontal or slant?
Slant.
We're going to have a slant. Okay, how do I find the slant?
Division.
Division. So now look at this problem and think back of your division skills. Would you like to use long or synthetic, or can I even use synthetic actually? My divisor in this case would be x minus 1. So based on that, can I use synthetic? You can. Or you can still use long division. So it's up to you guys. We're just doing this together, so I'm going to do whatever you guys want to do. Do you want to use long division or synthetic? Synthetic. Okay. So to use synthetic, you need to remember that this basically says x squared plus 0x plus 0. Right? So we set up the synthetic. This is going to be equal to, the dividend would be 1, 0, 0. Do we understand why? And the divisor is going to be a 1 on the outside. Are we okay with that? Cool? So with synthetic, remember, we drop the first number, so that's 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 0 plus 1 is 1. Remember, the last number is known as your remainder. Okay? Now, if you divide it, in this case a quadratic, by a linear, that means that this right here, if we bring back variables, would be x plus 1. Agreed? If we have a remainder, in this case it would be plus 1 over x minus 1. Do you guys remember that? Okay. Here's the thing. For slant, you will always ignore the remainder. Okay? Always ignore the remainder. Your slants would be located at y equals your quotient, which in this case would be x plus 1, ignoring the remainder. So I'm going to repeat that one more time. After you do the division, you can ignore the remainder, and your slant asymptote will be located at whatever your quotient is. Cool? All right. So we've got holes, we've got X-intercept, asymptotes. What else do I need to check?
Crosses the asymptote.
Okay, does it cross? So how do I check that again?
Set f of x equal to asymptote.
Good. Question, do I set the original equation or do I set the simplified equation?
Simplified should be better, right?
Simplified. You can set the original if you want to, but look at that versus this. I would definitely, trust me, after you find the holes, you use the simplified for the rest of the problem. So we're going to set x squared over x minus 1. Is that equal to x plus 1? That's where our asymptote is. Agreed? Okay, once again, I'm going to help you out. If I put that over 1, I can use cross multiplication. So that's going to give me x squared times 1, which is x squared. Is that equal to, what's x minus 1 times x plus 1? X squared minus 1. Agreed? Okay, so now I got to solve this. So I'm going to subtract x squared from both sides. That goes away, though. That's 0. Is 0 equal to negative 1? No. So does it cross? It does not. Cool. So I think now we have everything, and then if we need to find points, we'll find some points. Here we go. So we've got a vertical asymptote at x equals 1. And then I have a slant asymptote at y equals x plus 1. As a pre-AP class, I do expect you to know how to graph that. And I do expect it to be graphed correctly on the test. Okay? So x plus 1, it's in the form of y equals mx plus b, which means it has a y-intercept at 1 and a slope of 1, right? So I can help me out by plotting some points. It's going to look something like this. And I'm just going to represent it by a dotted line. Oops, I messed up, didn't I? And let's see if I have some white out, which I do. There we go. So that's what my asymptotes look like. What else do I know? I know some X-intercepts and a Y-intercept, and it happens to be at 0 for both of them. So that would be right here. And I also know the location of a hole. The location of the hole is going to be -3, -9/4. -9/4 is approximately what as a decimal? 2.25. Good. So -3, so that'll be -1, -2, -3, -1, -2, -2.25 would be about right there. I'm going to do a little open circle to signify a hole. And now I'm just going to use my definition, the knowledge that I have about the definition of an asymptote, which in this case means that if I'm here and the hole is in this location, that means I have to go this way, and I have to continue to go in that direction. Now, question. Here, do I go up and back down, or do I automatically go back down? And why? The multiplicity was 2, so you should just turn around. Cool. If you were to go back up and then turn back down, guys, wouldn't that mean that you would have to have another x-intercept? Which you don't have. Okay? So that's what that part looks like. I'm going to go ahead and guess. My assumption is that the other part is going to be on the top, but let's make sure that it is. So we're going to find out one more point. So what would be a good x-coordinate for us to use?
1, or not 1, 2.
2. So if we go up here, let's say we go 2 square is 4, 2 minus 1 is 1, so we've got the point 2, 4. So 2, 4 would be 1, 1, 2, 3, 4. And then this thing should look something like that. So we've got everything with the exception now of the domain. So my domain is going to be all real such that x does not equal what, guys?
1.
1. We need another number as well. Or this time we have another number.
The whole.
The hole as well. You can't be at the hole. So what is the x-coordinate for that one? -3. So our domain is going to be all real numbers except -3 and 1. Cool? Alrighty. That was a lot. It's been a long lesson. I know we've been here for an hour. But do we have any questions? Yes, sir.
So where the slant asymptote crosses the x-axis, why did we not count that?
Why did we not count it as far as what?
As far as domain, can be with the vertical asymptote.
Right, so the vertical asymptote is at 1.
Slant, like slant.
Yeah, I mean, but the slant doesn't matter because look, think about it. Like, if you plug in 0, you still have a point. If you plug in -1, you still have a point. -2, you still have a point. So the only numbers that you're gonna exclude from the domain will always be your vertical asymptote and your holes. The slants will never play a role into domain. Cool? Good question. Anything else, guys? Alright, so I was recording this. I'm going to go ahead and stop that recording.